Hey guys, I want to show you how to graph inequalities and how it compares to graphing an equation. All right, so let's start with this equation here. We've got y equals 1 half x minus 3, and so we plot our y-intercept first, and then we follow our slope, which is 1 half, so that means go up 1 over 2, up 1 and over 2. Okay, so we plot our line, we draw a line. That's simple. This line represents all the possible solutions. So every point on here, like the point 60 or the point 5.24 and negative 0.38, or the point 0, negative 3, or the point negative 2, negative 4. All of these are solutions. They make this equation true. So what happens when this becomes an inequality? Well, an inequality has a lot more solutions, infinite solutions. And so I want you to notice what happens with this greater than or equals to symbol. So when we graph y is greater than or equal to, we shade the values that are above the line because y is greater than, right? And so everything stays the same. We still use a solid line because those values are included. That's the equals to part, right? It shares that in common with the equation, the or equals to. But now we're shading above the line, okay? Now take a look at what happens when we go less than or equal to. Now we're shading below the line because the y values are less than. And notice right here, what's less than negative 3? Well, negative 4, negative 5, negative 6, and so on. So those points are less than. I also want you to notice the importance of 0, 0. Let's plug in 0, 0 into this inequality right here. If you plug in 0 for y and 0 for x, you'd end up with the statement that says 0 is less than or equal to negative 3, which is false. 0 is not less than or equal to negative 3. So that means 0, 0 right here, this point right here, is not a solution, which is why it's not shaded. We shaded the other direction, below the line. Now what if it does not have the or equals to symbol? Let's take a look here. All right, well, notice it looks very similar to the greater than or equal to. The only difference now is that we've used a dashed line. And the reason we use a dashed line is to show that these values on the line are not included. They're not solutions because this does not have the or equals to. And that's very similar to like what we said before with the plotting inequalities. Like 5 is not greater than 5. It's equal to 5, but it's not greater than. All of these have to be greater than. So we use a dashed line to indicate that. And this still says y is greater than, and so we shade above the line. Let's use 0, 0 as our test point here. 0 and 0 means 0 is greater than negative 3. That's a true statement, and notice that 0, 0 is shaded, so we shade towards the 0, 0 in this case. All right, and last but not least, y is less than 1 half x minus 3. We shade below the line, but we're using a dashed line. So going back to our original equation and comparing these, what's different? Well, what's different is we have shading. So sometimes we'll shade above the line, sometimes we shade below the line. And then what's different also is the type of line we use. Sometimes we use a solid line, but if it does not have the or equals to, then we use a dashed line.